Welcome to Crypto Radio. We interview the top thinkers and entrepreneurs in the blockchain and cryptocurrency industry. We also cover topics like trading, investing, and ICOs. We're your hosts, Mike Gilliland, Michael Pohl, Chris Sparks, and Yuvi Ivanova. We're entrepreneurs, crypto investors, and co-founders of a new blockchain investment platform called CoSyndicate.io. We created CoSyndicate and Crypto Radio to make crypto investing a better experience for you. If you're new to the show and you'd like a list of our top episodes and resources, go to cryptoradio.io/start. If you like our podcast, you can subscribe, share, and follow us on social media and leave us a rating and review on iTunes and elsewhere. It helps others find the show and we really appreciate it. You can find all those links at cryptoradio.io/start.
Hey Crypto World, my name is Yuvi Ivanova, and welcome to the new installment of our Thought Leader series on Crypto Radio. Our guest in this episode is Trent McConaghy, AI and blockchain researcher and the founder of Ocean Protocol and BigChainDB. Trent is on a mission to democratize data and help ensure that humanity has a role in an increasingly autonomous world. We discuss how AI and blockchain technologies can help one another, how artificial intelligence DAOs work, and how humanity can maintain control over its systems in the future. For all the show notes and resources from this episode, go to cryptoradio.io/trend. This episode is brought to you by BitGuild.io. BitGuild is a new gaming platform built using blockchain technology. Their mission is to redefine the relationship between gamers and game developers. On the BitGuild platform, gamers maintain full ownership and control of their virtual items, which are stored on the blockchain. They can transfer items and progress between compatible games, and they can make in-game transactions safely and cheaply, and sometimes free. Developers who join the platform will get a direct link to an established player base with a strong community and a network of like-minded developers building on the same platform. Developers will also have the potential for direct game development funding from BitGuild. BitGuild just completed their token sale on April 5th, 2018, in which they raised 35,000 ETH, or just over 13 million USD at the current market rate. If you want to find out more, go to cryptoradio.io/bitguild. That's BITGUILD.
Trent, thanks for joining us on the show. Can you give us a bit of a background, how you got into these industries, and just tell us a bit about yourself?
Sure. So I was raised in a pig farm in Canada and then became an AI researcher. That was actually really, truly my first job that wasn't working on a farm. And I did that while in undergrad. I was doing undergrad in electrical engineering and comp sci in Canada. So from sort of, people starting to pay me to do AI, I started a company straight out of undergrad, which was AI for designing computer chips, sort of focusing on creative AI side of things. That was the late 90s and built that up. And me and my co-founder sold it in the early 2000s, about 2003. And from that, I did two more projects related to AI. One of them was my PhD, which was sort of reconciling human creativity with machine creativity. I did that out of Leuven, Belgium. And the second one was a company that was AI for computer chips as well, but really focusing on challenges with Moore's Law. It was looking like there was some issues where sort of process variation, sort of tolerances going haywire was really going to hurt Moore's Law and the ability for chips to keep getting smaller. So started a company for that and did the PhD, did that company. That company got acquired fairly recently by Siemens. So that's kind of my AI background. I've been doing AI for a long time then. And in terms of the Bitcoin and the blockchain side, I learned about Bitcoin in 2010. And in 2013, I really dove much more deeply into it and learned really about blockchain. I kind of kicked myself for not looking more deeply into what powered Bitcoin earlier. But 2013, I started really getting into that and fairly quickly realized that you could do a lot of super interesting things. So we've done three main projects, myself and my co-founders and the team around us. The first was Ascribe, which was for digital art, IP on the blockchain more generally. That project started in 2013 and shipped in production in February of 2015. So that was the first. We ran into issues of scale that led us to be building BigChainDB, which is a blockchain database. And more recently, we've been working also on Ocean and Ocean Protocol. It's substrate for decentralized data and compute focusing on AI. So it's really helping to address these issues of data silos that we're seeing that AI is causing. And Ocean is designed to change the incentives away from silos towards true democratization of data and AI services. So that's really what I'm up to. In summary, did AI for almost 20 years and blockchain for about 5.
So in the last few years, the idea of AI coupling with the blockchain and blockchain enabling AI is sort of a protocol platform for this. there's been one kind of idea about this, and you said recently it's been evolving and changing. So what was the idea about how AI would be used on the blockchain, and how is it looked at now?
Yeah, so there's a lot of potential actually intersections between AI and blockchain, and I think we've only scratched the surface of the possibilities. So in some cases, AI can help blockchain. In some cases, blockchain can help AI, and in some cases, you have things that can't really exist unless both AI and blockchain are present. So I've been sort of asking myself this for years, and sort of the first real zinger that emerged that was over drinks with myself and Simon DeLuvier and Greg McMullen was this idea that you could have AI agents, AGIs, they're called, artificial general intelligent agents, living on a blockchain, a decentralized substrate processing, something like Ethereum or something. And if you have that, then these things can run around and they can actually have their own wallets, of course. So therefore you have these AIs that accumulate wealth that you can't turn off, right? Unlike some sort of like traditional AI, you can always unplug it, even if it's running in the cloud. Bezos could unplug it on AWS or something, right? And then there's actually tons of ramifications for that. That was really kind of the first realization, like, oh wow, right? And these things can even get rights if you frame it right. Get into that later. And I called those AI DAO, artificial intelligent, decentralized autonomous organizations. So that was kind of an idea from almost 2 years ago now. And after that, I started asking, what are the different ways that blockchains can help AI? And there's some very simple things like having the provenance of the training data and the provenance of the compute. And all this really matters. Like if you have a self-driving car that crashes, then ideally you have some sort of black box, just like airplane black boxes that give you sort of an idea of like, okay, what led to this crash so that we can improve things in the future, right? And so that was just provenance of the data, where it came from and how the compute happened and so on. It can be very helpful. And there's some other sort of tweaks here and there too, how blockchain can help, for example, in terms of bringing people together for incentivizing on tokens. A good example on that is Numerai, where they're actually a community of data scientists that are collectively driving this hedge fund. And they're all incentivized to work together because they all have the shared token, Numeraire. And they're, of course, for this hedge fund, they're contributing AI algorithms, and then they get sort of paid in terms of Numeraire based on how well the hedge fund does. So that was a few things, and there's quite a few more. But something that, as I was writing about this and exploring this, all roads seem to point to one place, and that is the problem of data silos. So traditionally, AI has led to basically modern AI, deep learning, all this. That's a lot of, the most popular form of AI these days, really thrives on data. So the more data you have, if you have 10x or 1000x more data, then you can bring your accuracy from like 60% to 90% or 99.9%. And that can make all the difference between, a successful product or not. And after that, all about, how much revenue you make and stuff. And so companies are really incentivized to gather lots of data. And of course, they don't want their competitors to see that. So they're incentivized to hoard that data, which leads to data silos. And what we realized with blockchain was that you could actually change the incentives from data silos to democratizing data. And that's partly via data marketplaces, but then also going even more deeply because you want to have not just priced data as in data marketplaces, but data commons. And, if you do things, if you have a good design for your sort of incentive structure, then you can actually address that. That's kind of what I'm thinking about with Ocean. So that's a bit of a sampling. There's a lot of other cool things too out there that different projects are doing that are pointing the way, that are really helpful for AI. SingularityNet is really going for decentralized AGI, especially. You've got OpenMind, which is going for training a neural network that's decentralized, that no one owns or controls, that is respecting privacy in really, really strong ways, and other projects too. So lots of different AI projects out there enabled by blockchain. Blockchain doesn't enable AI, but blockchain can help remove a lot of the centralizing tendencies that AI has. And at the same time, it can help enable new features in AI, such as these AIs that can own themselves, like these AI DAOs.
Yeah, I'm interested actually in the incentive structure because, like you said, with the kind of centralized entities, the incentives are very different than what they look like on the blockchain. So how are you guys setting that up, and what kind of incentive structures do you see being developed in the future?
Yeah, for sure. So I just have a few words on incentives. First of all, I have to admit I was pretty late to the game in understanding the power and importance of incentives. And even in working on BigChainDB and so on, we really focused on the other benefits of blockchains, the decentralized aspect, where you're kind of spreading control and power, the immutability aspect, where you can get really great provenance, and then the assets aspect, where you can, you own something if you have the private key. And those are really nice characteristics, really helpful for improving efficiency and maybe even unlocking some new features. But, to me, I came to realize over the years, especially the last couple of years, that the most powerful thing of all is that blockchains are incentive machines. And in that, I mean, you can use them to structure incentives, but especially in the sense of mining, you can basically set up a machine that no one owns or controls that can get people to do stuff. And why would they do this stuff? Because they're getting paid in these tokens that, the network provides in magic internet money. So I provide value to Network X. Network X gives me tokens back in return. For Bitcoin, for example, it wants to maximize its security. It defines security as hash rate. So if I help contribute to the hash rate, then I can expect Bitcoin tokens back in return. So that's wildly powerful, and it's much more powerful. Like, some people have understood that for a long, long time, but more and more people are starting to realize that now. I was a bit of a late bloomer, but now I've really come to understand that. And then with that understanding, I've come to realize, wow, like, there is a whole sort of space of possible designs here that you can go for in designing this. And realizing that was very useful in designing Ocean. And, towards your question then of what does the Ocean incentive structure look like to address this problem of data silos? And the answer is the Ocean network gives you tokens if you make data available to the network when asked. And how many tokens you get is a function of how many tokens you have staked in a curation market sense. So the more tokens you stake, the more block rewards you get when you make that data available. Ocean actually isn't. So overall, Ocean, it's a service that's designed to maximize the supply of available data and services as in other compute services and so on. And then it plugs in various networks that provide data or services rather than trying to do that all itself. So that's its overall objective function, if you will, maximize the supply of high quality data and services. And then it manifests that via this block reward that I just described, where the block reward is you get block rewards proportional to how much you have staked and whether, anytime you make that data or service available. So that's basically the core of Ocean. It's a very simple structure at the very, very core, but we think that's really, really important that you keep that very, very core thing simple and powerful, just like Bitcoin has demonstrated in the past.
Yeah, I'm interested actually in how incentive structures look like for AIs. Because when you have something autonomous running, then you start thinking about how can you direct it? And perhaps having incentives would be one of the ways to do that.
Yeah, for sure. I mean, I think there's a whole variety of things there, depending on how you kind of look at things, right? If you think about training a traditional neural network or a deep network, they don't really have incentives per se because, you just run them with someone controlling it, right? And they're just meant where, you're given some training data, you build this model for classification or regression or whatever, and then it's just run. So it's sort of like this machine that's pretty dumb in that way. It's just a mapping, right? Just a function. Then you have, when you do things like running evolutionary algorithms, it's basically a form of optimization usually, where then the question there is, what are you trying to optimize for? And you can think of that as sort of an incentive, right? So evolutionary algorithms, you're basically having survival of the fittest towards maximizing or minimizing some objective function. So it could be, for example, where you're, say, trying to maximize the top speed of a car, right? You're designing a car, you've got some sort of car simulator, and then you generate 100 different random cars, and then you see how fast when each one goes, and the ones that are going the fastest, you let them stick around and make babies, and then those babies make more babies and so on. And there's always a bit of mutation and crossover and stuff going on. So overall, then the babies that stick around and have babies and more babies, those are the ones that are faster. So an incentive function there, which is, the top speed. This, however, as well, is controlled by the person, right, who sets it up. And overall, there's a person who kind of has control of this. But then you can start generalizing a bit, right, towards, AGIs and agents, where these agents kind of run around and you have simulated worlds. And traditionally, these agents run around in a simulated world where, one entity is controlling that. You maybe have agents running around in OpenCog, which is one of the sort of more prevalent agent simulators out there for virtual worlds. Think of it like Second Life for AIs, right? So you can have these agents set up their own incentives, and they can run around. These agents can be very simple. Think of it like ants, right? Or you could have like 10 ants or 10,000 ants, super dumb things running around, maybe having some sort of emergent intelligence. But of course, once again, there's sort of how much can they truly have incentives if there's some sort of overarching controlling entity, right? But the amazing thing is once you start putting agents like that onto a decentralized substrate where they don't have to rely on any humans to like flip the switch, keep them on, keep them running or not, if they have an ability to sustain their wealth or even accumulate wealth, then it completely changes the rules about incentives, right, for AIs. Because now suddenly it's kind of like, as long as they have the resources to keep going, to keep replicating or to keep running, they can do whatever they want, right? And so that's actually the major change that just happened. And I guess there's a bit of a middle ground, and that is if you think about traditional computer viruses, you can also think about them as kind of dumb AIs because they copy themselves from one machine to the next. And they're kind of basically stealing a little bit of compute resources, right? You don't really know about it. They're kind of hiding under the hood, but they can spread very quickly and they're sort of like their own sort of mini life form, right? But these new AIs that decentralized substrates enable, these AI DAOs, they're a really new game in town because they can have their own incentives. And no one has really like thought about that in a really deep way. It's actually sort of very philosophical and profound. And that's a great question. Like, how do you want to program incentives for these AIs? That's a great question, right? No one has great answers.
So it sounds like you'll probably get a lot of the same questions over and over again about the dangers of putting AI in the blockchain, such as creating profit incentives for them to potentially go rogue with, or the fact that you can't shut them down. I'm sure there's even more beyond that. So how do you answer those kind of worries that people might have?
I usually start off by enthusiastically agreeing that we have to be super thoughtful about this. It really is sort of an atomic bomb that is like super powerful, and most people don't realize that it's this powerful, right? And if you think about, the atomic bomb, it had pros and cons, the atomic energy, right? You can make a bomb on one side and you can have nuclear power on the other side, which was, promised a lot of great energy, although it has its own drawbacks, of course. Same thing here. It's really a double-edged sword, and sort of there's negative and positive scenarios to all of this. So definitely that's the first thing to understand is it's really powerful because it could sort of exponentially grow very quickly and accumulate a lot of resources. And maybe you can't shut it off, or maybe, maybe on Ethereum or something, there can be a hard fork. Who knows? Or maybe it'll just swamp the net so that everyone gets sick of it, kind of like CryptoKitties, although people didn't get that sick. So then the question is, do we have examples and what can we do about it? And we actually do have examples already. And I'll preface with Nick Bostrom wrote about something called the paperclip maximizer. You guys might have heard about that. So, this AI agent, it's given the objective function, maximize number of paperclips, and it's given access to a lot of resources. So it just, converts every single atom on Earth to a paperclip, right? And never mind the humans, we're all becoming paperclips too. That's because it's optimizing for that. And I saw this myself too in building AIs, right? Where you build an AI like to try to design a computer chip, say an analog circuit, an amplifier, and it will give you an amplifier, but it will cut a bunch of corners because you forget to specify those corners. And it comes up with some ridiculous wonky designs. And then if you want, you can try to add in constraints bit by bit by bit, but that's really hard and can take a long time. And maybe you'll never get the right answer. How I solved it was I managed to give it rails according to sort of human biases of what a good design is and what isn't. That was sort of the heart of my PhD, to actually reconcile sort of these objective functions run amok, reconciling that with human sensibilities. So I've thought about this a lot. So that's sort of an example from AI land. And there's a lot of challenge there. Like in general, whenever you're designing optimizers, how do you actually come up with objectives and constraints to match your intent? And that's not much different than computer software programming, where a bug is basically mismatch between intent and implementation, right? So in blockchain land, we actually have something similar too. And some people like Ralph Merkle have called blockchains life forms, right? These sort of things that are out there that people feed them, they kind of live on the resources of others, but they give rewards in return, like tokens and stuff. And so, Ralph Merkle and others have called these life forms. Now, going back to the paperclip maximizer, imagine if there was something out there, maybe a blockchain, that had an objective function that worked so well, and it just kept going and going and going that it started sucking the energy out of the planet. Well, guess what? This blockchain that's out there that's set to use more energy than all of USA by mid of 2019, just over a year from now. It's already using more energy than most countries, right? It's called Bitcoin. So Bitcoin is actually kind of a paperclip maximizer. Now, is it going to suck the life force out of the whole planet eventually? Probably not. It's going exponentially now, but it'll hit the top of an S curve almost certainly. But we actually have a bit of this right now, and that's basically objective functions gone haywire, right? I don't think Satoshi anticipated that it would go this far, but it has, right? But we can use that actually as sort of a warning signal for when we're doing our own token designs too, right? It's a sort of like, oh my God, Bitcoin's objective function is wildly powerful. It's good to understand because what can we do to safeguard against ones that kind of do damage to the planet that way, right? We don't really want a blockchain that's eating the energy from the planet, right? It's better if it can have more useful work, for example, like storing files, like in Filecoin, or making data available, like in Ocean, or other things, right?
I was just going to ask basically what are some of the good solutions that you can think of other than proof of work?
Proof of work, that's actually part of the solution where you're not just trying to solve some crypto puzzle that's some might argue is useful, but it's clearly more useful if you can actually be storing, like having something that there's not even an argument of whether it's useful or not, right? Things like, storing data or whatever. But overall, I've thought about this a lot actually. And I think at the end of the day, you want to make sure that there's a structure to change the incentives on the fly without easily being gamed, right? Because that's sort of the get out of jail free card. Because generally you're going to have humans who are owning tokens in this thing, having a stake overall, or running the mining. And so collectively, those miners or those token holders can have some form of governance to change things. And it can be just via a hard fork. That's sort of the simplest form. Although we've seen with Bitcoin, hard fork, no one has been even really proposing to hard fork Bitcoin to reduce energy. But the good thing is there's competitors coming along too, so we'll see. But the other end of that spectrum is on-chain governance. And, we're seeing examples of blockchains out there that have been running now for a while, where the on-chain governance seems to be working, right? Things like Decred and Dash, right? And, we've had other forms of on-chain governance in the past that have had sort of major flaws. They cause real issues like BitShares, real issues within that chain, not beyond. So this is a good sign. And that's sort of the fallback of basically, even if you launch the thing, knowing that you have some sort of get out of jail free cards for a while, That's useful. The other things are just sort of from the time, let's say the white paper is written to the time that the network gets deployed to try to get the best understanding of what the dynamics of the system could look like, right? So part of this could be via simulators, like token simulators, and there's actually a few groups working on those. And that will be helpful, but it will only cover a fraction of the overall possible things because this is an economy that's kind of open-ended. Humans are part of it, right? This sort of dynamical system. So you can't really model what's going on inside humans' heads, and they're going to try to game. So what you can do then is, though, as sort of a simulation process, to have humans in the loop in a simulation process. And ideally, where there's more and more skin in the game towards the public launch, right? And I can see that that can be very helpful too, because overall, the idea is to try to model all the facets of the system towards the public launch of the system, such that overall, it's, you're pointed in a good direction. So overall, there hopefully won't be major global changes after that. But at the same time, you have this get out of jail free card called governance.
There was something interesting that you said that I'm kind of stuck on. You said that Satoshi didn't anticipate that Bitcoin would be using this much energy by this point. But wasn't that part of the design? Wasn't this kind of predicted that it would be using this much energy at this level of scale?
Well, that's a good question. Actually, I said the wrong thing. I don't know if he predicted that or not, but he actually did not anticipate mining pools or ASICs, right? And he really, if you go to the white paper, you'll see that he talks often about sort of one human, one miner. So like more like us running a miner on each laptop or each smartphone, as opposed to 5 or 7 centralized entities that are running 95% plus of the mining power, right? So Bitcoin is veered in a slightly different direction, very actually big different direction than the initial vision. It's still serving a very nice value to the planet, as well as, a demonstrator of what's possible. I guess it's to be debated whether or not Satoshi saw the issues with the energy of the planet. The good thing is Bitcoin right now, it's still, it's humans running it. So hopefully they will see that, hey, probably not a good idea to have a machine that's using more electricity than all of USA. There's probably a more efficient way to get as much security or 99.99% as much security without drawing up so much energy. So that's to be determined. We'll see. But my main point with all of this is actually that like Bitcoin is an amazing example of how powerful incentives are, as well as a super interesting example of sort of like this life form, this DAO-like entity. I call it a super dumb AI, if you will, right? That actually has sort of its own way of being. But of course, we can have these AIs living on top too, and a much richer design space than just like raw blockchains because of all these tools of AIs like recurrent neural networks and these fancier AGIs, right? Like the AI on blockchain space, it's already starting to grow really rapidly in the last 6 months, but it's going to still be unrecognizable 2 years from now. We're going to start to see really sci-fi-ish stuff happening. It's really hard to imagine, but it's coming.
When you kind of sit back and imagine what the future looks like, what do you come up with? What are some of the crazier fringe ideas that you see that could be possible within like 2 to 5 years?
Yeah, so, and I don't know if it's crazy or fringe, but I have a couple of approaches to this. One of them is I actually, I'm a big nerd, huge nerd, so I love to read sci-fi, and there's some sci-fi novels that kind of paint pictures of the future of how this could be. So one of them is a book, actually 2 books, Damon and Freedom PM by Daniel Suarez. And sort of at the beginning, we're at sort of present day at the beginning of those novels, but by the end of them, with sort of technology that there's no magical technology happening. It's just sort of basically one computer process kicking off another based on news and other events. By the end of the novel, there's swarms of self-driving, self-owning Cadillacs driving around, smashing into buildings and doing their own thing and stuff, right? That's kind of one example without actually any major leaps of what's going on. And not just the swarms of the Cadillacs, but overall, just various swarms of things, AI agents interoperating with humans, and sort of all the rules of society have been completely rewritten. And it just happened in this very gradual process. In its case, it was written as a bit of a thriller, so it's a bit more dystopian than it needed to be, but it was still very informative that way. Another one is actually Kevin Kelly wrote this seminal book back in the early 90s called Out of Control, and it talked about sort of the emerging AI at the time with things like genetic programming, which is evolution of your programs, things like ant colony optimization, these sort of swarm systems where you have a whole bunch of AIs. Each one of them is super dumb. It's just no smarter than an ant, just in fact much dumber than an ant. But you have 10,000 of them together, and they can start doing amazing things. And it's things like this that I see. I think actually the stuff that's going to happen 2-3 years from now, we're going to see a lot of swarm stuff happening, because we can build these technologies today where it's just like one agent that is super dumb, just has some basic knee-jerk reaction to something else. But if you combine 10,000 of those, there's going to be some crazy emergent properties, and that's going to be really hard to predict as well. It's sort of like if you ever play with cellular automata, if you type in a rule for updating, the squares around a single square, depending on the parameters of the rule and so on, it can be a very simple rule. You change your parameter by 0.1, and it gives you sort of radically different emergent patterns, right? And all of this is rooted on the idea from sort of complexity science, right? where from very, very simple rules, you can have a lot of complexity emerge, and it's actually very, very hard to predict what will happen. But I can see that like swarms and agent-based systems really lead that way. So that's a couple examples where I see we could have headed, and those are probably the two best examples of books. But beyond that, or kind of complementary to that, I also see in general, these AI DAOs, you can frame them positively or negatively. The negative way we've kind of talked about a bit where, we might actually be incentivized to give them control of our systems in order to be capital efficient. So throughout the 90s and 2000s, all the semiconductor companies, the chip makers, used to have their own fabs, their own factories to build chips, everything from Texas Instruments to whoever, right? Sony. But they actually all sold their factories because the factories got too expensive and they really wanted to have the best return on the capital, and they focused on design and then just outsourced the capital to a couple players that would manufacture for them, most notably TSMC. So now we only have 4 major organizations in the world that do manufacturing. 2 ones that take outsourcing, that's TSMC and SMIC, and then the 2 biggest semis, which is Intel and Samsung. And that's it. Basically, everyone else just designs and outsources, right? And we're seeing this in other industries too, like BMW. They sold their factories and they just focus on design. So basically, the idea is capital efficiency. So if you're Uber and you're rolling out, a self-driving car fleet, do you want to own all those cars yourself? Do you want to try to get other people to own them? Well, a third option is simply to get those cars. Each one of those cars, basically, it owns itself, but it's sort of got a loan to buy itself out. And over the span of 5 or 10 years, it buys itself out. And Uber would be happy with that because it keeps the capital off their books, right? And, each car is its own corporation, so it would have rights and stuff like that, right? So in doing this, we can do this for fleets of self-driving cars, fleets of self-driving trucks, energy grids, roads, all of the above, right? So you can frame this as a negative thing in that, oh crap, we're giving up our control to the bots. But there's a positive framing too, and that is nature 2.0. So it's this idea of, nature 1.0 is the wind and the trees and the soil and the carbon around us, where this cradle of civilization, where kind of humanity grew up on this and all the species around us. But now, we've been building these machines, especially since the dawn of the Industrial Revolution, that don't really play well with nature. But what if we could actually have machines that are much more nature-like, that interact locally, that take in resources from the environment and then convert them to something that's useful to the rest, like a tree taking in air and humidity and like CO2, nutrients from the soil, and then converting that to things that are useful for everyone around. Well, we can, a self-driving car could be like the same sort of thing, right? Where it's taking in electricity from the grid, maybe even from solar panels on its roof, helping to move humans around in this sort of symbiotic relationship and sort of adding value, but not owned by anyone. So whereas nature 1.0 is soil and carbon, nature 2.0 is silicon and steel, and adds silicon and steel, and it would be in symbiosis with nature 1.0. That's sort of a positive framing of it all. And, we can get there gradually, bit by bit, by offloading some of our capital to these benevolent bots.
Yeah, really interesting part of this is that you can use simulators, and obviously they're probably pretty resource intensive, but for certain things they would be worth it because, if you could simulate a bunch of different scenarios before you actually go and deploy things, then you can avoid all kinds of catastrophes or just inefficiencies. Whereas in nature, it actually has to physically try each iteration, each mutation, and then, you just end up with a bunch of these mutant things or, just kind of evolutionary dead ends or death and destruction. Yeah. Where in this case, you could do a lot of that in a simulated environment and it doesn't actually cause any harm other than just using a bunch of power.
Yeah. And I mean, evolution is massively parallel, right? We have trillions of trillions of trillions of cells out there, each with their own DNA, basically looking out for itself and evolving in parallel, right? So that's very valuable, but definitely before we hit the world of atoms, if we can simulate to a degree in the world, in the digital world, that could save a lot of pain. But there is a caveat, and that is even in the world of circuits, which is supposed to be a fairly closed system where it's well defined, I discovered that it's actually really hard sometimes to basically the simulator can lie sometimes. And, for something that's supposed to be simple. So when we start having systems that involve interactions with nature or interactions with humans, oh man, right? That's going to be hard to simulate at any level of accuracy at all. So I see it right now as more of a linting thing where, maybe you can detect 20% or maybe if we're lucky, 80% of the potential issues early. But then we still need to basically iterate towards trying to capture more and more of the issues before we deploy live, right? And overall, though, it's sort of like this grand experiment that we could still screw it up. But that's no different than sort of the world as it is anyway, right? When people discovered that coal was really useful for energy, they never understood the environmental consequences. They just ran with it, right? Then 100 plus, 200 plus years later, it's like, oh crap, this is really terrible for the environment. And, we've scrambled as a civilization to clean up our act there in a literal sense. And I can see that there are going to be things that get deployed, maybe to nature 2.0, all of this, that might look good at first, and then 10 years down the line, 50 years down the line, it'll be like, oh crap. And we have another example of this too, and that's the social media like Facebook, right? It's like, oh cool, I can connect with my friends. I don't even have to pay for it. I only have to watch an ad now and then. Well, that actually had sort of the way that Tristan Harris frames it, it's aligned incentive structure, and I agree fully with that. Kind of the way I think too, because if someone is extracting information about you in return for ads, they have completely different incentives than you. Whereas if I was paying for that service, then the incentives are much more aligned, right? So, and that's sort of an oh crap thing too, almost 20 years after social media was invented, we were realizing the issues around it, right, with the data silos and so on. So that's sort of a near-term crisis based on sort of a misunderstanding of the vast power of sort of Web 2.0 social networking. And there's going to be stuff happening in sort of the Web 3.0 / Nature 2.0 world too. But the good thing is a lot of the community and the world of blockchain and stuff is very cognizant of this. Myself and many others we're really, really trying hard to understand what the implications are and to give ourselves as many sort of get out of jail free cards as possible as sort of a community, right? Understanding that this stuff is wildly powerful, right? AI and blockchain are two technology each on their own, wildly opinionated, right? You can't say, oh, it's just code. It's not just code. Every time you deploy a piece of AI, every time you deploy a piece of blockchain software, it is infused with opinion and ethics. So if you don't design for the ethics, then you have a bad design for ethics, right? So basically, that's kind of the core, right? We'll never be able to have something perfect, but we can at least try to avert the big errors and give ourselves, ways to improve wherever there's errors that emerge.
Can you expand a bit more on the idea of self-owned AIs and use the example of a vehicle buying itself out? Can you expand on that idea a bit more?
Basically, I'll just give the recipe. In fact, before I do that, I'm going to give a very, very, an even simpler recipe so that it's easier for your audience. So I call it the Arch DAO. And how it works is, I'll use Ethereum as an example because it's, the most prevalent blockchain out there for decentralized processing. So I create a smart contract that, of course, the smart contract can hold its own funds, right? That smart contract has a very simple bit of AI code in it that can automatically generate art. It can be using some evolutionary algorithm. People have been doing that since the 90s, or maybe some deep learning, like these deep dreams from a few years ago. And let's say every time it generates that art, it costs, say, $1 worth of Ether, right? Because it can be pretty random. It doesn't need to be great. It has to be just interesting enough for people to buy. But then let's say it sells that for $10. Okay. So now it's got $10. And it owns that, right? Because it's out there running as a contract. There's no one controlling it at all. All the ties have been severed, went on launch. And then once it has sold that, and by the way, to sell it, it just posts it for sale on some centralized or decentralized marketplace, but let's say Open Bazaar. And actually there's, a fair bit of art, digital art on Open Bazaar, decentralized marketplace. So it sells it, makes $10 worth of Ether. And then with that, it creates 10 more artworks, sells each of those. Now it's got $100. Sells those. Now it's got 1,000. Keeps going, growing geometrically. And before you know it, you've got $1 million, the world's first AI millionaire. And it's amazing because it's actually owning this itself. It's running on a decentralized substrate. No one can shut it off unless they shut off all of Ethereum or hard fork Ethereum away, right? So basically you can't shut it off. And it's fascinating. It's just the sort of like life form that's up there. It's pretty dumb. All it knows is how to generate art and get wealthier, right? But now take that idea that I just described, and if you think about it, these dollars or Ether that it's holding, those actually could be keys to control resources in the world of atoms in meat space, right? So, for example, therefore, if you can control keys, you can control a resource, right? Just like you can think of it like our brain has a resource to control the body, right? It's got access control to the rest of the body. So my brain can control my body, right? So this AI DAO can control a car, right? So it's the brains of the car can control the car. Brains aren't living in the car or just in the car. They're also living in some decentralized substrate, right? So it's basically manifested a body for itself, this car that's driving around, and it has its own wallet, just like the Arch DAO, right? And now instead of accumulating resources by selling artwork, it basically accumulates resources Uber style, right? So maybe it hooks into the Uber network, and whenever a person comes along, that person says, okay, take me here. They drop that person off, they make $10, right? And they drive around and make $10 here, $10 there, maybe say $1,000 a month, right? And of course, to start with, they've actually been like, how do they buy themselves out, right? And so actually, quick background, when the DAO got going, in 2016, they actually set themselves up as a corporation in Zug. And Zug has it set up, Zug, Switzerland has it set up where you can basically remove the people. So basically, you can have a corporation that isn't attached to any people. And of course, corporations have rights, right? Corporations are people too, they have personhood. And so imagine you take something like the DAO that was set up, but actually you remove all the people, but it's a corporation. Then imagine Uber, the company goes along to it and says, hey, here's a contract where you have access to this car, you can control this car, but you owe us, right? You owe us, say, the $20,000 it costs to buy this car. So you can pay us out, $1,000 a month for 20 months, right? So it does, right? It earns $1,000 of profit per month. 20 months later, it has bought out from Uber and it fully owns itself, right? Not unlike a mortgage or regular car payments, right? So there you go. After 20 months, you've got a car that it's a DAO in the sense of it's a process living on a decentralized substrate like Ethereum. It has its own resources, including its own body that it has actually bought from Uber, right? And it's not just Uber. Mercedes could do this, or Daimler could do the same thing, right? What a way to sell cars, right? They create their own customers. And actually, they kind of did that in creating Car2Go back in the day, right? And BMW with Drive Now, all this. So there's actually precedents there too. So yeah, that's basically a manifestation, right? It's pulling together a few of these already existing precedents that we have with the idea of, corporations that have personhood, and that goes back hundreds of years, extending that into the DAO, where it had personhood as well, essentially, where there weren't humans involved at all. And then, merging that with ideas from AI DAOs, starting with the Arch DAO, which, is accumulating wealth as a smart contract using AI technology. And then finally merging this sort of Arc DAO idea with sort of the DAO idea into this car that's owning and controlling itself. And by the way, two people might have asked on that, what if it breaks down? Well, it'll just call up a contractor to come along to fix it. And then it'll have other automatic contracts too, here and there for various things, right? And yeah, maybe if it does really well, it'll buy out a whole fleet for itself, right? Who knows?
I love this idea. And I love the idea that you could also have these autonomous devices, the Internet of Things devices kind of operating with minimal desire for profit so that the costs are always driven down and down and down. So as long as their expenses are paid and they have working capital, then they can just keep operating and then people would take the benefit of that.
Yeah. Actually, related to this, you might really like this part. So I should say this idea of sort of the Nature 2.0, where you have lots of these things, sort of these swarms of these cars and swarms of these trucks and electric grids and roads. I've been sort of co-developing this with JP Dumernik from Annexus, who's based in the Netherlands. And with this, he had this idea, which I think is great. Imagine the car is paid for itself and it keeps going and it doesn't have really incentives to get super wealthy. What if all the excess funds after that go straight to UBI, right? So basically you can have this sort of Nature 2.0 enabled by AI DAOs that can then help to pay humans for living themselves, right? For basic income. And not just basic, keep going up Maslow's hierarchy all the way up to, universal self-actualization income, right? To me, that's fascinating because, Uber has massive revenues per year and many other things because it costs money to do things in meat space, right? So these things that cost lots and lots of money, imagine if that's actually going directly back into, a universal income.
I love it. Yeah. And it's such a more efficient method of quote unquote taxation than tax would actually be, because you've still got the corporation sort of entity and structure behind it. So there is incentivization for efficiency and maximizing that efficiency, but still, the profits can be returned to the people. Quite interesting.
And if you think about what governments are, right? Like what is the different governments have a few roles, right? But one of the big roles is to basically have a mechanism to pool resources that pool money from people toward creating shared resources, right? Resources for the commons, whether it's roads or otherwise. And that made sense as a technology from, a couple hundred years ago. But now we have blockchain as another way to organize a bunch of humans towards doing things, right? And done in a way where you don't even need the humans involved anymore, right? And I think that's really wonderful, pooling, the resources of humans such that you get these fleets of cars and roads and so on to manage it all.
I love it. Trent, this has been a really fascinating conversation. I hope we can get you on again sometime in the future. And thanks again, Trent.
Yeah, sure. My pleasure.
To get the show notes from this episode and find the links to Trent's projects, go to cryptoradio.io/Trent. To check out our sponsor, go to cryptoradio.io/BitGuild.
If you're new to the show and you'd like a list of our top episodes and resources, go to cryptoradio.io/start. If you like our podcast, you can subscribe, share, and follow us on social media and leave us a rating and review on iTunes and elsewhere. It helps others find the show and we really appreciate it. You can find all those links at cryptoradio.io/start. And finally, if you want to be a sponsor of our show, go to cryptoradio.io/sponsor. Thanks for listening and we'll see you in the next episode.